Hello class, my name is Nicholas Akkad. This is my Project 2 presentation. Have you heard of the terms top-down and bottom-up? I bet you don't relate them to how your phone was designed. I digress. Let me explain my research question. Probably wondering how I got from cybersecurity to designing hardware and software to my current revised question of why does our software design process, while hardware becomes limited, need to develop for the future? So cybersecurity and new languages were more of an interest rather than a question, and didn't tackle anything specifically. And then the second one, it was very broad and had multitude of solutions that didn't really go into any specific research. I'm going to explain my synthesis map categorization and relate sources at the same time in order to explain my research process. As you can see, large map, colors, but hard to read, bulky words. Over here, I condense it into a table. If it's green or says yes, that means the source does have a relation to the category. So I'm going to go into the specifics. The first categorization was the process. So these were sources that had the process of SDNs or explained how models work or explained how current programming languages are designed. So source 2 dealt with the top-down model and the bottom-up model. The top-down being the model where it tackles all problems at once and goes down to a single solution versus the bottom-up where it starts with a base and then spreads out. In reality, the bottom-up is easier to implement, but source 1 and 5 show that the top-down model, which SDNs or software-defined networks are based off of, can overcome many things such as bugs and virtualization. On top of that, it also is how current programming languages such as Python and C++ are designed. The next category is effectiveness. So source 1 explained how both models, top-down, bottom-up, do have issues. However, the issues of bottom-up are near impossible to deal with starting from that design process. However, the top-down model can not only be reprogrammed, reused, and recycled, as well as have better security options for us in the future. Source 4 goes into more detail about this. It shows that because of SDN's virtualization, we can actually switch off nodes during cyber attacks. And finally, source 5 went into specifics on how hardware that is stronger beats multiple weaker hardware, simply put. The next categorization was the implementation of the top-down model, or the SDNs. So source 3 dealt with how smaller companies could implement it in a simple way, while source 5 is how large companies have already implemented it, such as our cellular networks. This goes down into specifics, but basically the smaller companies, as we see in the next category of cost, can purchase a small CPU for a relatively cheap price, anywhere from $200 to $5,000. Still, it's more cost efficient compared to buying a full SDN. And then furthermore, the cost category also included the environmental benefits and economic benefits of SDNs, because they are, generally speaking, green due to the less amount of software needed, as well as the fact that the processes don't take as much energy, among other things. So I did have a couple issues with the sources, mainly that data is based on theoretical for most of them, and then translating data to writing was difficult to explain simply because there was a lot of functions and numbers. So how would I deploy this literature review? I would show that a large amount of testing is still needed to be made alongside the development. I would argue that we should implement the top-down model partially in order to aid data collection and deal with some current issues. Simply, we need to tackle current issues gradually and make progress. Thank you.